Can we optimize this method? Can we optimize this method? I hope this method is very clear to you. Now let us see the optimal method. Idea clear, right? Now let us see the optimal method. This is a traditional method. Now if Anil Nair is solving this question, how I will solve the question? N plus S of n is equivalent to 2000. N plus S of n. This is that first method is the traditional method which you will find in regular textbook. Anil Nair's way of solving. If this question is given to me, probably you can solve this question in 10 seconds Anil Nair's way. Two methods I will tell you, any method that you can solve. Now if you see here, Anil Nair's way, let me apply digital sum on left hand side and right hand side. Digital sum of n plus S of n is equivalent to digital sum of 2000. I am applying digital sum function onto the left hand side and right hand side. Digital sum of n is given by sum of the digits till you get a single digit number. S of n itself is sum of the digits. Digital sum of 2000 it is 2 plus 000, it is 2. That means S of n plus S of n, 2 S of n it is 2. That means S of n it has to be 1. That means sum of the digits has to be 1. Sum of the digits it has to be 1. Sum of the digits it has to be 1. First point it is clear, right? And the second point which we did is n is a 4-digit number. N is a 4-digit number. N is a 4-digit number. 4-digit number. So if it is A, B, C, D, it cannot be, A cannot take any value greater than 1. 2000, even if I keep all zeros, 2000 plus sum of the digits 2, 2002. It is exceeding 2000. A cannot take 2, 3, A cannot take any value from 2 to 9. A cannot take 0 because A is in the leftmost. That means A will be 1. A will be 1. A will be 1. I hope the point it is clear. Now B, what value it will take? Think logically. B maximum value it is 9. Let us not take the maximum value. Let us take 8. Let us take 8. Let C and D be the 9 and 9. If it is maximum 1899, what is sum of the digits? 18 plus 9, 27. 1899 plus 27. Is it reaching 2000? It is not reaching 2000. So this is not possible. B8 not possible. Any value less than 8, it is not possible. That means B value has to be 9. 19. What should be the digital sum? 1. What should be the digital sum? 1. So 9 plus 9 over 1. 1 means this can be 1990. 1990. Or this is 1, this is 9. 10, 1 plus 9, 10. Digital sum 9 means it should get 19. 19 means extra 9. Extra 9 means this can be like this. Yes or no? 1 plus 9, 10, 10 plus 9, 19, 10 plus 9, 19, next one, 19, this can be 1972, 1972, this can be 10, 19 I should get 63, this can be 1954 and so on. But this is not possible. Why? Because 1 plus 9, 9 plus 9, 18, 18 plus 1, 19. It is not reaching 2000. These cases it is not reaching. 7 plus 2 plus 19. 9 plus 9, 18, 18 plus 1, 19, 19, 19 plus 72, 1991, these also not reaching. Here it is 19, it is exceeding 2000. So the only case is 1981. Without even finding the values of A, B, C, D, you can find out what is the number by using digital sum concept. Apply the digital sum on the left hand side as well as right hand side. Digital sum of a number is sum of the digits. I applied modulo 9 on left hand side and right hand side. S of n plus S of n, it is 2. 2 S of n, it is 2. What is S of n? S of n, it is defined as sum of the digits. S of n, it is defined as sum of the digits. Sum of the digits, it has to be 1. Sum of the digits, it has to be 1. A cannot take 2 to 0. A will be 1. If it is 8, 1 plus 8, C and D takes maximum 9, 18 plus 9, 27, still it not reaching 2000. So B cannot be 8, B has to be 9. Sum of the digits has to be 1. 1 plus 9, 10. 10 plus 18 digital sum is 9. 19 digital sum is 1 plus 9, 10, 1. So it has to give sum 9. 10 plus 9. So these two digit sum should be 9. These two digit sum should be 9. These two digit sum should be 9. So the cases that is possible is 1981. Very, very good question. Sir, can you tell any other way of solving the question? Method 3. Method 3. Idea is to give you multiple ways to solve the question. What is method 3? N plus S of n equivalent to 2000. N plus S of n equivalent to 2000. What is that we discussed? N cannot take a single digit number. N cannot take a 2-digit number. N cannot take a 3-digit number. N cannot take a 5-digit number. 5-digit number. This is something which is there. So n has to take a 4-digit number. A 4-digit number, right? Starting with 2, that is also not possible. So it has to be 1. If it is starting with 2, 2000 plus sum of the digits 2. 2000 plus 2, 2002. So it is not possible. So here it is 1 and sum of the digits. If you observe closely, A, B, C, D. A, B, C, D. If A, B, C, D all are 9, 9, 9, 9, 9, 9. What is the sum of the digits? 36. That means these upper limit value, it is 36. Upper limit value, it is 36. That means n first digits has to be 19. Are you all with me? Right? Upper limit, it is 36. 2000 minus 36, 1900 around. So n is 19. Other two digits we don't know. Let me call it as xy. Is it clear why the hundreds place and thousands place cannot take 18? Because if it is 18, 1899. 1899 plus 36, it cannot give you 2000. So this will give you 1900, x is in tens place, 10x plus y, it is 2000. 10x plus y, it is 2000. So 10x plus y. Are you all with me? 10x plus y. So these 19xy plus sum of the digits. Sum of the digits is 1 plus 9, 10. 10 plus x plus y. Are you all with me? I am using this equation. N plus S of n equivalent to 2000. So 10x plus y plus 10 plus x plus y is equivalent to 100. Are you all with me? So this will become 11x plus 2y equivalent to 90. 11x plus 2y is equivalent to 90. Now if you see here, 11x equivalent to 90 minus 2y. 90 minus 2y. 11x equivalent to 88 plus 2 into 1 minus y. 2 into 1 minus y. 11x equivalent to 88. This is divisible by 11. This is divisible by 11. So this should be divisible by 11. That means y has to be 1. If y is 1, 11x equivalent to 90 minus 2, 88. X equivalent to 8. X is 8, y is 1. So the answer is 1981. Answer is 1981.